In this video, we're going to look at a transmutation example. So here's our question. For the following U-235 fission reaction, calculate the energy released per fission and per kilogram of uranium-235 reacted. We've got uranium-235, which combines with a neutron to produce strontium-94, xenon-139, 3 neutrons and energy. We've got the resting masses of our U-235, our neutrons, our strontium-94, and our xenon, and all of them are in atomic units. Okay, so let's find out what the energy is per fission. So first off, we've got to work out what the mass of the reactants are. I'm going to call that MR. Okay, so what have we got? Well, we've got uranium-235, and that's got a mass of 235.04394 atomic mass units. Then I've got a neutron, and that neutron number is 1.008665U. And I'm going to add them all together, and that gives me a total of 236.05261 atomic mass units. So that's the mass of the reactants, and now we've got to determine what the mass of the products are going to be. And I'm going to call that mass of the products MP. So we've got our strontium-94, and that comes out at 93.9154 atomic mass units. Our xenon-139, which is 138.9184 atomic mass units. I also have 3 neutrons, so I must multiply my mass of neutrons by 3. So it's 3 times 1.00866665 units. If I add these all together, what I get is a total of 235.58598 atomic mass units. Now we notice that MP is going to be less than MR. So the mass defect will basically be calculated by MR minus MP. Well, MR is 236.05261 and MP is 235.8598. That gives a combined mass defect of 0.19281 atomic mass units. Now I need to convert U's into kilograms, or atomic mass units into kilograms. So 1 U equals 1.66 times 10 to the negative 27 kilograms. So if I multiply the mass defect of 0.19281 unit by 1.66 times 10 to the negative 27, I get a total of 3.2 times 10 to the negative 28 kilograms. Now I can use that in E equals mc squared, where E equals the energy, m is the mass defect, and c is the speed of light, which is 3 times 10 to the 8 meters per second. So I substitute in my mass defect from earlier, 3.2 times 10 to the negative 28, and then multiply it by 3 times 10 to the 8 squared. That gives me a total of 2.88 times 10 to the negative 11 joules. That's the energy per fission. So now let's look at part B. In part B, I've got to work out what the energy is per kilogram of uranium-235. So basically, all I'm going to do is I'm going to take the energy that I had and multiply it by the amount of energy for a whole kilogram. So I know that the mass of uranium-235 is 235.0494. I'm going to convert it into kilograms, multiplying by 1.66 times 10 to the negative 27. That gives me 3.9 times 10 to the negative 25. So that gives me, we know that 1 atom releases 2.88 times 10 to the negative 11 joules of energy. So 1 kilogram will be that value divided by 3.9 times 10 to the negative 25, which gives me 7.38 times 10 to the 13 joules of energy. Wow, that's huge. That's what generates a nuclear bomb. Okay, hope that makes sense. Thanks for watching.